Well, I'd like to start by thanking the organizers and also the morning speakers for what's turning out to be a really fascinating discussion about a topic that I think deserves much more interdisciplinary and open discussion. Artificial intelligence has made really dramatic progress in the last 10 years. If you want to think about and realize how much, just think back 10 years to February 2007. In February 2007, there was no such thing as an iPhone. In February 2007, if you talked about seeing cars driving themselves on the highway next to you, people would think you were science fiction. Back then, if you even talked about having computers that could reliably translate back and forth between Japanese and English, that sounded pretty far off. But today we have all of these things and more. Today, I can pull out my phone, I can speak to it, it understands what I'm saying well enough to execute the command. If I go to take a picture, before I even click the button, the camera has analyzed the scene before it and spotted the different faces so that it can focus on those. So AI has come very far, very quickly. Now, the point of my talk, the main message of my talk, in fact, is this, that AI is having two fundamental impacts on us, and is likely to have much more. One is that it offers the opportunity for great advances in our standard of living, improving our personal health, relieving congestion and pollution in our cities, increasing the productivity of our workers, improving government effectiveness. The second impact, though, is that because of these dramatic changes, it's going to challenge us to rethink many things, our ethics and our laws, the systems we have for distributing wealth, the economic systems, even our sense of self as individuals. So what I want to do with this presentation is review some of the recent progress in AI, extrapolate that to some of the progress we may see in the coming decade, and then step back and look at the implications of that for society and the individual. So let's start there. One of the areas in which AI has made dramatic progress recently is perception, such as computer vision. What you see here on the left is part of a standard test set that's used to challenge computer vision algorithms and to measure their competence. And the goal of the computer vision algorithm, given any one of these, there are about 1 million images. Its goal is to recognize what are the objects in that image. And there are about 1,000 different objects. What you see to the right is the dramatic progress in the performance of the best available computer program for this task over a 5-year period, going from error rates close to 30% to now human-level competence at this task, around 4% error, which is what people make when they have to identify these objects in these images. So a lot of improvement in a short period of time. Similarly, in speech recognition, we have the same kind of phenomena. Microsoft, in fact, announced last fall that on one of the major standard data sets there, using switchboard speech, they had reached human-level competence. Similarly, in robots, we now do see occasionally self-driving vehicles on the road, but robotics is making progress in other areas as well. Self-flying vehicles, robots underwater, robots operating in the fields of the farms, in the mines, and occasionally as a vacuum cleaner in our homes. Yet another area where there's dramatic progress is game playing and reasoning. So last year, as many of you know, the AI program AlphaGo defeated the best human Go player. And other AI programs have defeated the best humans in other games like chess and poker. So there's a lot going on, a lot of progress suddenly. What's underlying this progress? The answer is primarily machine learning. So there's been a switch in the strategy of AI researchers, which further back was a strategy of trying to write down algorithms line by line. And the switch is to instead try to train them by showing them examples. And to understand this, think of the following task. Suppose I asked you to write a computer program to recognize your mother in photographs. This is something we can all do ourselves. But if I ask you to write down the algorithm, you will fail. At least everybody who's ever tried to do that has failed. And if you even think about how you'd write down instructions to me as a person, and you have to write down the instructions without showing me a photo of your mother, then you quickly realize how difficult a task it is. So it turns out, in fact, to be too difficult. But what's easy and what works very well is to instead train the program with examples. Show it, here's an example of a photograph, and there's my mother. Here's another example, there's my mother over here. Here's an example, there's a person, but it's not my mother. So with enough positive and negative training examples, the program can learn the subtle distinctions at the image level that distinguish your mother from others. And that's the idea of machine learning and training a program rather than to write down the strategy line by line. Now, the beautiful thing about this is that that machine learning strategy is very generic. And so it can be applied to many other problems. In fact, it's currently being applied to thousands of commercially important problems. Instead of classifying images of your mother, we could classify electronic medical records of patients according to whether they should be diagnosed with pneumonia or not. Or classify those records according to whether a particular therapy will work or not. Or classify credit card transactions according to whether this transaction is likely to be fraudulent or not. So machine learning and the collection of relevant data to train those systems is what's really primarily the driver of the sudden recent progress in AI. And this leads me to actually the first impact that I think AI has already had on us as a society. I think we're actually at the beginning still of a decades-long trend toward increasingly data-intensive, evidence-based decision-making across all walks of life. And that trend is being fueled by the growing volume of online data and machine learning algorithms. You could think of it as a trend, a kind of tidal wave that's pushing us toward a new age of empiricism, of decision-making based on data. So that's kind of where we are now. What's next for AI? Well, it's never easy to predict the future. I can't either. But one thing I think we can say confidently is that we're going to continue to see advances in the use of machine learning from big data as more and more organizations collect more and more data to, for example, understand which of their customers are likely to want which products, to optimize their internal processes, and so on. Another trend we may see over the next decade is the appearance of products we can buy to achieve superhuman vision and hearing. Now that AI systems are at human level in some of these perceptual tasks, why not have products that improve our vision? I wear contact lenses as a technology to improve my poor vision up to 2020. If I could instead purchase contact lenses or hearing aids that gave me even better visual acuity or hearing than standard, there might be cases where I would want that. Another trend we may see, this one might be a little further out, is machines that really understand text. We don't have those yet. Of course, we do have search engines that can retrieve for us documents that contain the keywords we're searching for, but those search engines don't really understand what that text means. On the other hand, we now have programs that can translate English to Japanese And those programs have to have a little bit more of a hint of the meaning of the sentences in order to accomplish that. If AI gets to the point of having programs that really can understand text, it'll be a watershed moment for all of us. Why? Because when computers read, they will read it all. They will read the million books that Amazon has, every web page, every news article, and they will be better read than you and I by a factor of 1,000,000. Search engines will disappear the way we think of them now. They'll be replaced because each of us will have a personal reading assistant. If we have a question, it will answer it directly based on what it can read, and it'll prepare a paragraph summary justifying its answer, along with citations to background reading that we can dive into if we want. So that's an example of something which may or may not happen, but if it does, I believe personally it will happen eventually. So when it does, it will have a dramatic impact. Here's another example. I think we're going to see a trend toward a particular kind of conversational interaction with systems. Right now we have very simple conversations with our phone. We might ask them the weather, they might tell us. But instead, here's what I'm interested in. There are a lot of apps that don't exist on my phone, which could exist. For example, I'd like to tell my phone, or have an app, that whenever it snows at night in Pittsburgh, it wakes me up half an hour earlier, sets my alarm earlier. But nobody has written that app, so I'm still waiting. But the trend that I think we're going to see this decade is that I won't have to wait. Instead, I will say to my phone, whenever it snows at night, wake me up 30 minutes earlier. It may say, well, I don't know how to do that. Do you want to teach me? And I will say yes. And I will say, here's what you do if you want to know if it's snowing. You open up the weather app, you go to the tab called Current Conditions, and if the Current Conditions field says SNOW, it's snowing. So what I've just done in that simple conversation, very natural to us humans, is I've basically programmed my phone. I've now given it a condition it can monitor, snowing at night, and something to do when it detects that condition. So the reason I think this is a really significant target for AI, and I think it's one that we'll be able to do within a decade, is that it effectively turns every single one of us into a programmer. So today there are probably hundreds of thousands or maybe 1,000,000 people who know how to write software for phones. This will change that number to billions, the number of people who own phones. And so the creativity, the customizability, the general pool of bubbling ideas of what we can do with these devices, the pool of people working on that will grow by orders of magnitude. Okay, so those are some of the things we may see coming. Let's step back and think about how these things will influence society and maybe our view of ourselves. Let's start by thinking about the impact on city life, and start there even just by thinking about the impact of self-driving cars, which many people think will be in cities within a decade. Of course, self-driving cars will have positive impact on traffic congestion, deaths, pollution. They'll drive faster. They will weave through the intersections the way humans walk down the sidewalk and just pass each other without stopping. Cars will also allow cities to remove a lot of the parking lots that are using valuable real estate and turn them into city parks. Why? Because the self-driving car, if it needs to park, could drive out of the city to a place where there's more free space. Cars will have sensors, of course, cameras and others, that allow them to drive, but those sensor data will be networked to the city, giving the city a kind of set of roaming sensors that are reporting back to give the gestalt, the full picture of what's going on in the city. That'll lead to instrumented cities, and what will the cities do with all that data? Well, they will apply machine learning to that data to learn, for example, to anticipate or to predict when a crowd appears somewhere, to predict whether, for example, that crowd is going to grow or shrink over the coming 30 minutes. And using that prediction, the cities will then be able to make more intelligent decisions, like whether to reroute a bus over there to help the people when they want to leave, or send some police there to prepare for the crowd that's going to be growing there. Cities might also use that network to, for example, clear a path if an ambulance needs to get through. They'll just order the self-driving cars to pull over. But they might also order other self-driving cars to drive up and block the alleys in case some human on a motorcycle comes through and accidentally would get in the way of the ambulance. So these cars are both sensors and actuators that can be controlled by the central city. This may also lead to new roles for government. If city governments are going to collect this data and act on it, maybe they will people who do those jobs better. If you're a security guard, being able to have superhuman vision will help, but it won't replace you. You also are there because you need to take action if something happens that requires intervention. And there will be others, intelligent workflow assistants, perhaps robots, computers that read in summary will influence other kinds of jobs. So the bottom line is that AI will have both positive and negative impacts on employment. It'll make humans better at some things, it'll eliminate some jobs, it'll create others. It will also hopefully improve our education, which is going to be important when people need to retrain to get a new job. There's interesting research on online tutoring AI systems that adapt the curriculum to the needs of the student. AI is already giving us new, more flexible ways to work. Think about Uber, which allows people to work when they want and not work when they don't want. The whole Uber business is possible because AI software is being used to match up drivers who are looking for a passenger to passengers looking for a driver. And other AI systems in Uber are being used to tell the drivers where to hang out so that they'll most probably find a passenger soon. However, the one that actually bothers me the most is that I think AI progress, whatever it does to total employment, and there are forces in both directions, is highly likely to further skew the distribution of wealth. So I look at it this way. AI progress is going to grow the total wealth pie. Who could be against that? But it's also going to worsen the skew in income and wealth. And who could possibly be for that? It'll worsen that skew partly because the jobs that will first be automated will be the jobs that don't pay very much. So those are already people on the lower end of the income scale. So what can we do? I think society can start now to improve access to education, maybe to debate ways of reversing this growing wealth disparity, and to consider the question of if we need fewer taxi drivers in the future, what do we need more of? Maybe medical workers or other things, and use that as a guide on retraining. So let me just finish up by taking a quick look at how AI might also change our sense of self. It's interesting if you think about it, the internet has already changed my sense of self. I'm actually a more social guy than I used to be. I'm more in touch with my family and my friends because of text messages and video conference calls that I can do remotely. I'm also more knowledgeable. If I'm in a conversation and need a fact, I go to Google, thank you, Peter, and look it up. But I think AI will give us even more changes. If we start wearing hearing aids that give us superhuman hearing, or glasses that give us superhuman vision, it's almost a biological change to ourselves. AI will also, I think, through many mechanisms, challenge our sense of who we are and self-worth. If a computer takes over my job, even if I get a guaranteed minimum income, I'm going to question whether I'm actually earning my keep and contributing to society. And intellectually, who am I if a computer can do better anything that I'm trying to do? So I don't know the answers to all these questions, but my goal here is to raise them. I think they're important trends. We don't really know exactly how AI is going to develop, but it is moving fast, and I think some of the things here will happen. So I hope that this helps feed into the ongoing discussion today. Thank you.
So now we move back into conversation mode. We're going to have a series of conversations. The first is going to be between Peter Norvig, who is Director of Research at Google, and Professor Matsuo Kawato, who is Director of the ATR Brain Information Communication Research Laboratories. So, once the podium is out of the way, if I can welcome them on stage, please. If you go there. Thank you. Thank you.
So it's my great pleasure to interview Dr. Peter Norvig, who is Director of Research at Google Incorporation. And he previously directed the Google Core search algorithm. And he is co-author of Artificial Intelligence, a Modern Approach, the leading textbook in the field with more than 30,000 citations, and co-teacher of an artificial intelligence class that signed up 160,000 students, helping to kick off the current round of massive open online classes. I am a computational neuroscientist. I have been working in the field of neuroscience, utilizing humanoid robots to examine computational validity of some of our algorithms. And I am a Sony-made, Google-based smartphone, and I've been utilizing this a lot. And so one of the naive user of this smartphone, I have the following question, first question. So as Professor Tom Mitchell pointed out, Google achieved a very high correct recognition rates for images and phonemes by so-called deep neural network, deep learning neural network algorithm. And this was really one of the great breakthroughs in AI research. And combination of deep learning neural network and reinforcement learning in simulated video games and the game of Go was phenomenal. And a naive question from a smartphone user, how much of these technologies were already in this kind of Google Android-based smartphone? I've been using this for 2 years now.
Yeah, and there's a lot in there, and some of it is 2 years old or older, some of it is brand new. I think there's two classes of things. One are things that are obvious to the user and are just amazing new capabilities. So you can upload all your pictures, and all of a sudden you can search for them and find pictures of cats or shrines, and they're all automatically labeled, and you didn't have to do that yourself. And so that's a brand new capability. There's also some things where things just get a little bit better over time, and you don't really notice it. I think Tom Mitchell showed some good examples, right? So in addition to labeling the images, there's finding the faces, image stabilization we can do with these deep networks to understand what's going on and make your videos smooth. We can even do things like style transfer, where you can say, I took this photo, but I really want to make it look as if it was a Van Gogh painting. And we can do that. Speech recognition is another big area. All these recommender type systems. So what video should I watch next? What app should I install? That's all done through deep learning to make these kinds of recommendations. And I guess maybe behind the scenes, we heard a little bit earlier from Stuart Russell about machine learning as optimization. So there's some kind of back-end things that you wouldn't really think of. So how do we route your phone calls from one cell tower to another? Or when your data hits the data center, how do we deal with that efficiently? And that's all done through machine learning as well.
I see. Thank you so much. My second question is learning training sample large training sample necessary for deep learning neural networks. Deep learning neural networks, largest one is something like with 20 layers or even 100 layers. And the number of artificial synapses could be hundreds of thousands. Then usually we need 10 times more training samples compared with the degrees of freedom of learning system. So we were told that millions of images, tens of millions of games, and hundreds of millions of phonemes are necessary to train large-scale machine learning algorithms such as DLN. And it is announced that DLN are now practically used for machine translation. In this case, I believe that labeling a huge amount of training data or corpus should be necessary. How was this done? Was it by crowdsourcing with human power or some other more sensible method? And as a user, when we can use deep learning neural network-based voice Google search at home in English or in Japanese?
Mm-hmm. Yeah. So at Google and at our peer companies, there certainly is some amount of labeling where we would hire people to say, what's the correct answer here? Mostly we do that as a check after the fact.
I see.
And before the fact, we try to collect data that's already available in the wild, kind of natural data. And so for things like machine translation, we don't hire people to mark stuff up. We just go out on the web and find examples of documents. Here's a document in Japanese, here's the same page in English, and now we'll learn from those. And what the deep learning has done is enabled that whole process to be a single step. And that we used to go through and we had a 5 or 6 step process. So first we have to find the documents, then we have to say, this sentence in Japanese corresponds to these 2 sentences in English, and the next one corresponds to 1 sentence, and so on. Then we go in and break up the sentence into words and see which words correspond to which. And each of those was a separate program. They each had errors in them, and the errors kind of compounded, and we tried to minimize that. With deep learning, as you say, we have these networks with multiple stages, and we can do it all at once. And what that means is that we actually end up needing much less data. So we put in deep learning for machine translation. We got a big jump in quality. We sort of cut in half the difference between where we were and where human translators were, all in one step. And we did that with much less data because the data goes farther, partially because we're looking at it at multiple levels. We're looking at it at the sentence level, the phrase level, the word level, and even down to the individual character level. Also because we have a longer context. Rather than just looking at a small window of words, we can take the entire context of the whole sentence. And then finally, because we're able to do more generalization, that previously we had treated each word individually. Say, where does this word occur? And in order to say anything about this word, I need lots of examples of that exact word being used. With the deep learning techniques, we can now say, what neighborhood is this word in? And what similar words are there? And so I don't need examples for this exact word. I can have a similar word and learn over that. So we actually need much less data.
So how big is the currently used corpus? How many sentences and how many words?
Well, it depends for different tasks. And you know, it's very interesting that you had this rule of thumb of how many examples do you need per neuron. We also think of rules of thumb of how many examples do you need per class. So if we're doing like classification, saying is this a dog or a cat or an elephant, and you know, people say, well, maybe you need 1,000 examples per class. But you know, I think all this is also new. You asked when did this start? So for example, in speech recognition, we flipped the switch to use the deep learning in 2012, and then we made a big advance in 2015 by using what we call these long short-term memories, where we were able to look at more of the sentence. So we've just been doing it for a couple of years, and we're just starting to get this intuition for how much data you need.
Okay. So my third question is about the connection between AI or machine learning techniques with neuroscience and cognitive science. So cognitive scientists...
Actually, let me interrupt just a second before we get on to the third one. So one very interesting thing is that In some cases, we're able to learn almost with no data whatsoever.
Oh,
So one example is in translation. Previously, we trained each language pair separately. So if we wanted to go from Japanese to English, we had to have pairs of documents in those two languages. We're now able to make sort of a multiple step and translate between languages where we've never seen a pair of those two languages. So maybe we've seen Japanese to Korean, and we've seen Korean to English. If we didn't train it with any Japanese to English, we could still make that step.
oh, that's interesting. Okay. So my third question is about the relationship between neuroscience, cognitive science, and AI. So deep neural network was originally built as computational models of human visual cortices with many layers and feed-forward networks. But it is, in a sense, incomplete or impartial model. It does not include feedback connections or recurrent connections. Some versions already exist, but the original version is not complete model. And we have the feeling that humans can learn from much smaller number of training samples. For example, when I brought my daughters first time to zoo, they can easily recognize elephants versus giraffe.
Yeah.
But before that, I didn't show millions of images to my girls. They can learn just from watching from, say, 100 or 200 images. And people believe, neuroscientists or cognitive scientists believe that consciousness, attention, or categorization or dimensions are key to learn from a very small number of samples, which is still not possible with current major stream machine learning. So how Google research somehow incorporates neuroscience or cognitive neuroscience in future development of AI, which can learn from much smaller number of samples?
Yeah, so it's a big, fascinating area. And you're a scientist, I'm an engineer.
Okay.
And I think science and engineers coexist together and help each other.
Yes.
One thing I think is important is to make sure what you're doing, right? So if there's two peaks of engineering, building a product, and science, understanding what's going on, if you're aiming for both peaks at once, you usually end up in the valley in between, right? So you have to make your choice.
Yeah.
And so as a product company, mostly we aim for the engineering peak to say, we want to produce something that works well, and we don't really care if it's an exact model of how the human brain works. We just want it to work. But we're always very aware of what's going on in terms of science and trying to take advantage of that the best we can. So in things like doing the computer vision, we don't try to duplicate how humans work, but we're aware of what happens in the retina and in the brain. And we say, well, we've got to have color constancy, white balance when the light changes. We don't want to say, oh, that object has disappeared and a new one has replaced it. Or when the level of lighting changes, we have to have constancy over that. And to understand how that works, we look at models of how humans do it. And similarly, with speech recognition, we look at models of the ear and the cochlea and so on, and we're guided by that. But once we're guided, we just try to optimize the best we can. And we certainly do have examples. So I mentioned this machine translation without having seen an example of the two languages. So we call that zero-shot learning. We also have one-shot learning where we show a single example. And those tend to work when we have very detailed models of the domain. So there's examples of like character recognition where you can invent a new alphabet. And that can be learned in one example. But only if you have a very detailed model of what alphabets are actually like.
Yes.
And I think people can do that. We're not quite good yet at describing what those models are, but people also take a while, right? So maybe your kids are more advanced than mine, but I think most kids, they start off and they start calling every mammal doggy, right? And then eventually they learn to discriminate.
Okay, thank you. So my fourth question is about AI and robotics. So in the case of robots, especially humanoid robots who can walk and balance, when we have failure, it means destruction of the robotic apparatus. So in the case of supervised learning or reinforcement learning with humanoid robots which can walk, failure is not permitted, which is so costly and time-consuming. And so we expect very small number of training samples. It is said that human children can vigorously walk just after 1,000 falls. And how can current Google AI research deal with robotics? We were told that Google bought Shaft, Japanese venture, and Boston Dynamics. So we are curious about your general way of thinking.
Yeah. So robotics is hard because we have these more incomplete models of how the real world works. And so you can't do things in simulation. We do some simulation, but a lot of things you have to actually touch the real world. Yes. And when you touch and make experiments, things can go wrong. So we try to put bounds on what's safe and what's not. And we do try to basically encourage robots to play. So we have a room with a couple dozen robot arms in it, and we give them a basket full of objects, a glass and a bottle and a microphone and so on, and we just say, practice picking them up. And they pick them up, and sometimes they drop one. And from that, they learn, say that was the wrong way to grasp a glass. I shouldn't pick it up that way. I should pick it up this way. And they learn over time, and they communicate with each other. And so it's a kind of social learning where they say, hey, I figured out a way to handle this type of object. And over time, we see improvement. And I think it's going to take a while, right? So we're at this dawn of the age of robotics. It's harder to work with the real world than it is to work in simulation. It's much easier for us, say, to learn how to play Go, because you can play millions of games against yourself without touching the real world. Yeah. And we know exactly what happens. When I place a Go stone on the board, I know what's going to happen next. But when I grasp a glass, I don't know what happens. Is it slippery? Is it going to slip out of my grasp? Or am I going to crush it if I grasp too hard? We have these incomplete models of the physical world, and we have to learn them. And we have to learn strategies for being safe. And maybe it's not so bad if I break an object every now and then in the lab while I'm manipulating them. But when we're doing self-driving cars and so on, you have to be very, very safe. And so part of what we have to learn about is what is the right ways to do that. And we have various ideas for boundaries of safety. We do try to train robots similarly to the way a child learns. We have this thing called curriculum training, which means you start out with the easy questions or problems first, and then you build up from that. And so you can see the robots progress over time.
Okay, so we have still 2 minutes. So as neuroscientist and robotics researcher, I've been questioning some of the technical things. But for the last question, as a director of research at Google, what kind of future do you have in your mind, say 10 years from now? It's surprising that how many times I do Google search. Yeah. And it's surprising that now deep learning is better than human Go champion. And so it's a little bit scary, but from engineering point of view, you could make probably a practical, future prediction.
Yeah. So I guess I agree with the vision that Tom had in the previous talk of this communicating with assistants, and that every time we have a computer revolution, we change the way we interact with computers, right? So we used to type at a keyboard, one command line at a time, and then we got windows and mice, and then we got finger presses on a cell phone, and now it looks like we're at another transition point where we're going to be talking to personal assistants. And maybe there'll be a screen, maybe it's just a conversation, maybe there'll be different types of interfaces, but it won't be I select the app and then I push a button within the app. It'll be, I'm going to tell you what I want to do, and we're going to work it out together. And if you can do it for me automatically, great. If not, we'll have a conversation, And so this kind of breaks up the, not only how I see the interaction, but also has how the whole industry works. Because now you no longer have one big monolithic app maker who says, I'm going to make this app that's going to do all these things. Rather, you have pieces of conversation that all have to come together. And as an industry, we're going to have to learn how to make that work.
I see. Okay, thank you so much.
Take care.
Thank you very much indeed. Okay, straight on to the next conversation, which is between two old friends from Carnegie Mellon University, Professor Takeo Kanade and Professor Jeanette Wing, who is also Corporate Vice President at Microsoft Research and Consulting. So, may I welcome them on stage, please. Please.
Thank you.
So, you know each other well,
Yes,
so
we do.
20 minutes only, please.
In fact, we wanted to start this conversation by going back not 10 years, as Tom Mitchell did, but going back 30 years, when I was a young professor at Carnegie Mellon University, but Takeo Kanade was already this famous visionary, a pioneer in research in computer vision and in robotics. And I actually remember, and Tom will probably remember this as well, we went to a retreat for the computer science department, and as an after-dinner talk, Takeo gave us his vision for the future in computer science based on his work in computer vision. And I thought it would be helpful and interesting for the audience to hear how much progress we have made in computer vision, especially when I remember your example was this car driving down a lane and there's this white line that it tries to stay off of, but there's also a white picket fence and it's get confused between the white line and the white picket fence. And it was a very hard computer vision problem. And now we have self-driving cars. So, Takeo.
Well, I think my message is probably we have come a long way. And also, I think we still have to go a long way as well. I still remember, back in mid-80s, when we had early stage days of autonomous driving, we were actually driving only several kilometers per hour, you know? So we had to actually modify our car transmission so that it can actually drive that slowly, continuously, with a very poor vision, poor computer, and so forth. And then mid-90s, and we actually succeeded what we called No Hands Across America. We drove 3,000 miles from Pittsburgh to San Diego, but only 98.2% autonomous. Now, the number is impressive, but that doesn't mean any usefulness because you have to actually take care 2% of the time yourself. And it's amazing that 10 years after DARPA Grand Challenge, Urban Challenge, and Google Challenge, now the field has made it, the car without actually a driver. And then, as you see today, the car that has some capability of driving autonomously is now in sight, including the service of taxi and so forth. But I think we should realize, though, we have a long way to go because we are not there, I believe, that in any condition, any weather condition, can we actually trust 100% all the time. And for that, we have to have a genuine, complete understanding of the environment. Not only that, actually, we have to realize that as long as we are mixing human driving and computer driving, the most dangerous are indeed human, people who drive, because we don't know how they behave. And that is very difficult part of the game. And that's actually common in many advanced robotics and so forth, which maybe we should talk. So,
Well, one of the emerging areas of research right now is the combination of artificial intelligence and an area that I have done research in of formal methods and correctness and proving the reliability of systems. And the emerging area is now called safe AI. And the expectation is that when we have self-driving cars on the road, we want to make sure that those cars don't run over pedestrians and don't hit, telephone poles and so on. So how can we ensure the safety of these autonomous systems? And bringing in some of the technology and some of the science that we have done in program correctness and theorem proving and model checking and so on may be a way to help address showing how AI systems can be safe. So that's
I'm actually interested in hearing your perspective, and you have background of working in academia as well as actually government funding agency, and now industry. How to make this, how to actually leverage the new AI and robotics technology to genuinely and help human society, to make sure that they help. Well, what's our challenge and what's our responsibility as a scientist and engineer?
And I think this is a great segue into a topic that Takeo wanted me to speak to specifically in terms of the topic of our conversation is about challenges in science and technology. And I'd like to speak specifically about how the advances that we have made in science and technology are asking us to think about the implications on society. And the way I like to phrase it, and it's not due to me that I'm coming up with this terminology, is there's an interest in the social science community on what's called FATE: fairness, accountability, transparency, and ethics in AI. And to give you an example, for instance, with respect to fairness, we know all these wonderful machine learning algorithms do so well because they're trained on a lot of data. But if the data is biased, then the model that comes out of the algorithm will be biased. And then people will be making potentially decisions based on those biased models. So that's not a good thing. And we need to understand how to build fair models, how to make sure our machine learning algorithms produce fair models or feed in fair data. On accountability, there was a recent study by some of my colleagues at Carnegie Mellon and Berkeley which looked at targeted advertising from Google, by the way, and they discovered that higher paying jobs were being served to men over women. And so the question is, and of course, this got a lot of media attention and Google attention, but in reality, it wasn't Google's fault. The question is, who is accountable? Who is responsible for that? Because there's this large ad ecosystem behind the Google scenes. And besides, there are these algorithms that are actually automatically choosing what ads to serve to what person. And so is it the algorithm at fault? Is it the person who programmed the algorithm? Is it the ad ecosystem? That's a question of accountability. In terms of transparency, one of the challenges with respect to some of the deep learning technology is that they empirically produce fantastic results in terms of image detection and recognition, speech recognition, machine translation. It's superhuman. But we actually don't understand from a scientific point of view how these deep learning algorithms work. We can't explain to the end user why the model said this versus that. And this is becoming especially important when the EU, for instance, just passed the GDPR, which is Global Data Protection Regulation, that's going to be enacted in 2018. And one of the clauses in GDPR is right to explanation. So we have a challenge there. And the final one is ethics. And let me go back to self-driving cars. There's a canonical ethical story or challenge, which is when you have a self-driving car going down the road and it sees say an elderly gentleman in the middle of the road, but there are a set of little children on the sidewalk. Does the car go straight and kill the gentleman, or swerve to the right and kill the little children? And someone's going to have to make a decision, or the self-driving car is going to have to make a decision. And so that's an ethical question. It's an old ethical question, but it comes up again now that we have self-driving cars. So as a scientist, I don't really know how to answer some of these societal challenges. Do you?
That's well, I'm not sure if I have an answer. So now we're talking robotics. I think one of the things that I recently do is what we named quality of life technology. That's robot help people to, especially older people and people with disabilities. Now, in doing that, I think as a roboticist, I think I learned a lot, because the basic and implicit premise of robotics in the past has been to reduce human involvement, and that was a good thing. Because main application areas have been, say, like military, space, manufacturing, where reducing human involvement means a lot economically and also the capability itself. But when it comes to actually working with people, I found the premise should be different. Why? Because imagine that we have a robot system which helps as soon as you get up and then take you from bed to dining table and feed you, and then as soon as you want to, satisfy your some hygiene necessity, and then take you to bathroom and so forth. And when you sleepy, take you to bedroom and maybe sing a song for you. Now, I'm not sure if you want to live that way. Actually, it's opposite. I think you want to do as much as possible yourself, except a few things or little things that you may not be able to do, you want robot to help. In other words, I think the new way to look at new robotics is actually increase the human engagement. And for that, I actually came up with an equation, what I call the basic quality of life equation. That is, what robots should do is equal what human wants to do minus what he or she can do. And then plus minus delta, depending on whether you want to a little more help or you want to be challenged. And likewise, I'm pretty sure as an industry, the new application that you're looking at, and don't you have this type of different view toward the technology?
It's very much like what Peter Norvig was just saying in terms of, and also Tom Mitchell, in terms of the future of how humans will interact with computers and artificial intelligent agents or bots. We're moving into an age where we're going to be, first of all, talking to it, conversing, using natural language, And it'll be much more of a conversation rather than a question-answer. It'll be a long dialogue, perhaps many, many turns of turn-taking. And at Microsoft, we already have a couple of agents, one that we launched in China called Xiao Ice, that has really gone viral because from young to old, from all sorts of people from all sorts of walks of life engage with this bot and talk about not just the weather, but they count sheep, they can, they serve as psychiatrists, they can do all sorts of, they help school children with their math, and it really is quite engaging. And so I think that one of the things that I was going to ask you, Takeo, in terms of your robots and quality of life, is when you are putting robots to enhance the quality of life of some of the people that you worked with, some of the elderly, some of the people in clinics, didn't you find that you had to make sure that the humans felt emotionally engaged with the machine?
Absolutely.
Yeah.
Now, of course, it's interesting that when we discuss, well, that discussion actually goes into the very basic question: does AI system have, affection, self-consciousness, and so forth? And my belief, which may not be very popular around here, is that it does. It will, no question. Now, we have to realize that today's system, complexity of the AI system is still not enough. But I think it's getting there. Now, Professor Herb Simon, who's a Nobel economist, Nobel Prize winner, and also a computer scientist, a Turing Award winner, wrote a book, The Science of the Artificial. I think it's a very interesting book that I recommend you to read. He basically says that the science has been dealing with the nature, which does not necessarily have any sort of a goal, doesn't seem to have its own goal, whereas AI artificial system seems to have our own associated goal that we usually set up. And because of that, I think people may not have associated science with the artificial things. But when it comes to complex enough, I think that we should be able to study the behavior, complexity, design, and even the implicit, intention, quote, of such a system. And through that activity, I think we'll begin to have a new way to look at AI system, not as just a mechanical thing that we know everything. I think the complexity of AI systems still is too low. Therefore, human thinks that we understand everything. That's one of the reasons that people try not to associate typical human value with it.
So you think that in the science of the artificial, it will be as important to understand the behavior, including the emotions of the artificial, as we do for humans?
Yes, equally.
Will machines have different emotions than perhaps that humans have?
Could be, why not?
I mean, we humans are going to program these machines to have those emotions, right?
Yeah. well, that's what we think. But because
okay, they can invent their own. The machines can invent their own emotions.
Or we may associate it, because I associate your personality. I don't know your personality, but I actually interpret it. But by the way, I think I'd like to make one very important point of progress here. That is, we might think that the computer is strong, powerful enough to be close to the human. Not yet. Even the pure computational power, we are probably still order of 5 or 6 orders magnitude below. Not only that, The human brain is probably consuming about 20 to 30 watts or maximum 50 watts. Our supercomputer is consuming megawatts.
Right.
And this fundamental problem should have been solved. And what I heard today, like, you know, the molecular machines may be able to help us.
That's
here.
right, yeah.
Well, I think.
Okay, thank you, Takeo.
Well,
Thank you both very much indeed. Thank you. So now we get a couple more chairs. And we move on to one more discussion. And for this, I have the pleasure to welcome Edvard Moser, who is one of the 2014 Nobel laureates in physiology or medicine, Nicole de Wandre from the European Commission, and Professor Frank Pasquale, who's Professor of Law at the University of Maryland. So if you'd like to join me on stage. Okay. Nicole in the middle. Please. Thank you so much. Hello, everybody. So this session is billed as a chance to talk about challenges in science and technology. And one challenge that we all face is the vast increase in the amount of information we need to process and our difficulty in processing it all. And I'd like to spark a conversation between the three of you about that challenge. So, Frank, let me start with you. I know that you have serious concerns about the algorithms that we use to help us find our way through the information.
Oh, yes, absolutely, Adam. And I would say my biggest concern here is that even though the machine learning and artificial intelligence behind the algorithms at Google, Facebook, other massive corporations are fantastic at helping us sort through information, we should always remember Socrates' maxim that the best physician can also be the best poisoner, because on some level, if you know the body's physiology so well, you can also sort of undermine it well. And the worry that has emerged, and this is building on Jeanette Wing's excellent points about algorithmic accountability in the last session, is that we are seeing a world where sometimes people are being presented a picture of the information landscape that draws them into experiences or products or services that are harmful to them, like predatory loans, bad college courses, illegal drugs, or things like that. And so my concern is that as we embrace machine learning and other automated ways of organizing information, we simultaneously cultivate a critical distance and detachment that allows us to judge those systems as well.
And do you think it is difficult to cultivate that distance at present?
It's extremely difficult because a lot of the best innovations in information technology now are learning from the brilliant insights of the early behaviorists and others about, say, the effects of a variable reward schedule on conditioning behavior. And so you have apps that are often designed to be addictive. And while those may obey a certain economic rationality that is highly functional for those developing them, they can also lead to compulsive or addictive behaviors on behalf of users that can really undermine their interests.
Edvard, for you, information overload is a problem for you as well.
Yeah, in a different way, but I'm studying the brain, and one development that has taken place the last decade particularly is that suddenly we have access to information from thousands, and it will probably soon be 10,000, even 100,000 of neurons at the same time. So it's not long ago that we were studying one neuron at the same time and trying to figure out how that neuron contributed to behavior. Now we suddenly have access to all this activity at a millisecond time scale from so many neurons. And it's so much that no human brain can really alone figure out what's going on. We can have ideas, but machine learning, deep learning, I'm sure that is already coming into the field and will probably help us predict relationships between neural activity and behavior. But still, I think that will never be all, because with a biological starting point, as I have, I not only want to see relationships, I want to do more than predict. I actually want to understand the algorithms, the biological processes that go on. And for that reason, I think we need machine learning. It's very helpful in science, and especially in neuroscience. But we need something more, and at that point, I think we still need our own brains.
I mean, Frank, aside from the addictive nature of some of these tools, there's also the question of the way that the tools fragment society, if you like, by directing people towards particular worldviews. And I guess the same problem applies to science, that potentially the tools might lead you to have particular views of science that weren't the views that you perhaps should have. So could you discuss this question of fragmentation a little bit?
Yeah, I think when it comes to science, I mean, machine learning, to me, is just a technique that identifies relationships, but you have to interpret it afterwards. And I think all interpretations, scientific interpretations, are also affected by the person who does the interpretation. But maybe, I mean, when we use machine learning for scientific purposes, I think it's simply just like a technique that shows there is a relationship, and that's just a starting point. Whereas, of course, you can exploit it, as in the cases you mentioned, to actually change people's behavior. But I think that's an application that maybe is not so critical for us, because it's for us, when we use this in science, it is just a tool and nothing more. And we know the limitations of the tools too.
Yeah, I would just say, to briefly respond, that I am a bit concerned about the public sphere that we share in common. That's what worries me a bit. I just did a piece called The Algorithmic Self, and a companion piece called The Automated Public Sphere. And the worry is that as news feed and information is more and more personalized to us, we might be trapped in our own little bubble, and that this personalization, on the one hand, is serving us, but on the other hand, it could be like the Sorcerer's Apprentice in a way, and it could sort of move us to susceptibility to manipulation. So I think that fragmentation is very troubling. Yeah.
Well, what I think is that with this artificial intelligence that will be around us, we will be in between a single and same world for everybody and a purely fragmented world. We will remind ourselves that the world as we experience it is always perspectival and seen from different perspective and partial only. So I think that this information overload brings us to the shore where we have as humans to realize that our relationship to knowledge that we have built upon in the last 2 centuries is maybe too fictional, and this utopia of omniscience and omnipotence should be left behind now that we encounter more and more distributed intelligence. That should question our own relationship, I think, with intelligence. And to some extent, when we put ourselves not from the point of view of those building AI systems, but of those experiencing it, we will live in an environment where we have wondered for centuries if there was an intelligence behind nature. Now we will know there is an intelligence behind our environment, but how we experience it and if the effect of it will be what it was intended is a totally different story. So there is a really new learning situation for us humans to cope with this environment and to remember that we need to distinguish humans from non-human beings, at least politically wise, I think.
Because, we've been listening today to this idea of machine intelligence providing us with all the information that is out there, and we can somehow tap into it. That is not the scenario that you think will emerge?
When you say providing information, I feel that it is as if I would be a mere receiver. But I think that as human, we tend to underestimate, and we need to foreground this much more, how we depend on each other, not only to have things, but to know who we are. So all these interactions about the recognition of who we are because we appear among others. And also respecting our attentional spheres and the limit of our attention, not just to pay attention to things or to send instructions to iPhones and machines. Speaking is much more than giving instructions or teaching simple tasks. I think it is a lot about paying attention to others or to emotions. And the only fear I have is that we end up with our attention being sucked up by artificial systems, because they are very good at drawing our attention. That it is for our own benefit, I doubt. In most of the time, not. And the question of how much time I will spend with machine and with interacting with human, this is a balance we need to protect somehow.
And I just wanted to give a very concrete application of some of Nicole's really interesting theoretical ideas here in terms of recent elections around the world. Because it's one thing to, in an Isaac Asimov story, theorize about the possible freedom of expression right of a robot or a bot. It's another thing to witness election after election, as Woolley and Howard have documented, where Twitter bots get on. And when, say, an opposition to a certain candidate gathers on Twitter, bots come in, they overload the feed of people, and they end up disrupting the potential self-organization and collective intelligence of groups on these social platforms. And so preserving platforms as a space for collective intelligence among individuals is incredibly important and is going to be harder and harder, I think, as bots and artificial systems start asserting their own freedom of expression or ways of talking online.
There are two strands I'd like to follow here. One is the relations of humans to humans, which you beautifully bring up, and the collective intelligence. And the other is the demands on our attention. I mean, people speak about that a lot. They speak about the fact that everybody is now glued to their cell phone, and what does that do to both your relationships to other humans, but also the overload that it's creating in yourself, just so much information coming in. Let's talk about attention first. Let me ask you, Edvard, I don't know if neuroscientifically whether you can comment on the question of the demands on people's attentions increasing.
Yeah, well, I think it's clear to everyone, everyone knows this, that our attention is actually quite limited. There is a quite limited amount of information that we can take in at the same time. And the human brain, any brain, is very good at selecting the foreground and then ignoring everything. I mean, we know that from cocktail parties, for example, how well we can listen to one conversation and completely ignore more or less at least what's going on until something strikes out. But and of course this can be exploited. I think we have to be aware of this, because what I'm missing, or maybe I'm somewhat worried about in the way technology goes, is that I don't see for myself. I never have the time anymore just to sit back and relax and think, because there's always something going on. The latest is now when I came on the plane. I mean, usually I was thinking on the plane because there was no distraction, and now there's Wi-Fi on board, right? So I think that illustrates the development, that there is so much input. That's again back to the overload of information, and whoever wins the competition for attention has a huge advantage.
Please, Frank.
Just to build on that point, I really want to thank my airline carrier for making the Wi-Fi so expensive, because I didn't buy it. Then I got to read a ton of interesting stuff. And I think building on that, I think it's very helpful for everyone to think about, say, in their reading habits or media habits, what are they reading that is instrumental to some goal they have versus what are they reading that is sort of intrinsically important that might change what goals they have. I think that comes up in machine learning too. If we really want to have dynamic machine learning and deep learning, maybe you have to sort of dynamically permit a certain randomization or other ways of bringing other data into the training set. So I just sort of, yeah.
Yeah, and I think also, I think we speak of attention, but often in what I would call microeconomic terms. That is that we are supposed to pay with our attention for free services. And okay, that's a microeconomic approach to attention, but it doesn't take into account, it thinks that we can fragment our attention, like in our purse we have some cents and some euro or yens or dollars. And I want to bring the need to have a political approach to attention, to our attention. And for me, the attentional spheres of each of us is sort of part of our human integrity. So it is a fundamental right issue. And for the moment, we tend to frame fundamental rights in terms of control on data, for example. But if we were to control our data, we would spend our lives doing that and still be nowhere. So now that really we are navigating within this environment, we have to pay much more attention than to control issues and to frame in saturation terms our rights and not in control terms.
Please.
And I just wanted to build on that point by saying that there's a terrific movement called Time Well Spent by a former Google engineer named Tristan Harris. And he is trying to develop apps that help us understand how we interact with our apps and how they capture our attention. And so they would give you a report that said you're spending this amount of time on Twitter, this amount of time, the other computing systems. And I think that may help people manage a bit better.
But it takes more of your attention, again.
I like this idea of the fundamental human right to your own attention, or to time, if you like. Let's talk more about the other strand, what it is to be human. Nicole, do you want to expand on that a little more?
Thank you for that. Yeah, I think that, again, since 2 centuries, we learned that being human is being rational, so that it's a lot about knowledge, being in control. And I'm very much inspired by Hannah Arendt and her description of what being human is about, which she says it's about living in plurality, and that what characterizes humanness and men, she says, she means women mainly as well, which is that man in plural and not man with a big M and in the singular inhabit the earth. So that politics is about living within this plurality and not trying to position ourselves as in control of the world. So that being prudent and being meaningful and having ethical attitudes doesn't mean taking in charge everything, because we have to stay aware that we enter into a world that surrounds us, and when we die, we step out of it and it remains. So this sort of modesty and repositioning of humans within an environment and liaising to each other on the plurality base, which insists on the fact that we have an identity which has a revelatory character. We are not owning our identity. So ownership, control is not the only way to relate to something. Relating to each other is also learning that we are not omniscient, because the other one can hack your intention, so things can happen you didn't foresee.
So let me ask you how you apply that to the current challenge. How does that worldview fit with the current challenge of increasing information, decreased attention, the increase in AI? Can you encapsulate it?
And I would say it's by subverting the idea that everything can be thought of in causal terms, and allowing ourselves to consider the present as the new baseline, and where do we go from here, without feeling the need to obey to what was meant before us. So that doesn't mean not interpreting what came before, but taking this part of freedom, which is ours, to rethink as of today and to start from now. And also that if we are profiled, if we are interpreted, whatever, we are not bound to believe it, or we are not bound to, yes, it will constrain our choice, but our choice have always been constrained. We never came in a world that was totally made for us. So I think it's another form of contingency that is coming about.
Frank, do you want to pick up?
Yeah, I mean, I do think that this idea of looking at the world less in terms of sort of an unknowable other that's trying to control one, and more in terms of different opportunities that arise in order to sort of have more informational self-determination, is a powerful idea. And what I hope as law and policy person working in those areas is to figure out ways that government, other authorities can help us do that. Yeah.
Because if we think only about intelligence, man thinks either, if some think they are very intelligent and in control, good for them, but most of us think we are not, and then we feel we are controlled by others. So it's always an obsession on control and wondering if we are in control or under control. And I think it's a tiring question.
Edvard, do you feel in control?
Yeah, I think we are definitely controlled by so many influences that we don't know about. So that's a challenging issue. But I think, coming back to what it is to be a human, I think humans are social animals. So we live in a social context, and I think interactions with or our relations to other people, that is what defines us, and maybe for a long time will make us different from AI. And that includes, of course, how we all control each other, but I would probably go beyond that and not just put it in the control box. I would say that
we influence each other, but we don't control each
both
other.
positively and negatively,
Right.
but that anything we do at a millisecond to millisecond time basis is dependent on what's going on in all the ones that are around us. And that is a very, very hard thing, I would think, to regenerate in a computer. Maybe sometime, but I think this is very unique for humans.
Thank you all very much indeed. That's what the dialogue is all about, an interchange of ideas between fields, between science and society. Perfect. Thank you.
Thank you.
Thank you. So for the concluding conversation this morning, we move into Japanese, and we have a conversation between Nanre Yokota, who is a Zen master and chief abbot, and Noyori Mima, former director of the National Museum of Science and Engineering. Thank you. Please welcome them on stage.
So before start, this session will be running in Japanese. So please put on a simultaneous interpreter in the backyard. Is a very smart human interpreter. So, 違う。すいません、日本語でいきます。まずこのセッションに横田。
I have a pleasure of welcoming Mr. Yokota, who is the chief abbot. We have been discussing more about science and technology, but here we'd like to discuss human intelligence from Zen point of view. However, we have only 20 minutes. Yet, we hope that this session would help you feel about and experience about Zen. So how can we proceed? Well, good morning. My name is Yokota. I'm from Engakuji Temple. I have not won Nobel Prize yet. I'm looking forward to productive session. You know that if this is the football play, then you would feel that you are either playing in the home ground or in the competitor's ground, and that's exactly how I'm feeling, surrounded by scientists and engineers. So to help you feel about Zen, so let's sit straight. You've been sitting on the chair for such a long time and you might be tired by now. So try to straighten your back. Instead of leaning on the back of the chair, straighten your back. This is going to be a very short period of time, so please shut your eyes. And then put your both palms beneath your belly button, and then the center of gravity is not in your brain but in your belly. Then breathe slowly and then exhale from your nose very slowly and inhale again. And repeat that breathing for several times. Thank you. I really wanted to do this until the end of the session, but I guess I have to stop this for now. And now please relax. Now then, I'd like to begin a dialogue. First, about intelligence and awareness, the consciousness of the human, according to Zen teaching. How human mind or intelligence is generated, and who are we? Well, those are the questions that are common to all of us, whether we are from the East or from the West. And in view of such a fundamental question of who we are, according to Daisetsu Suzuki, the Buddhism philosopher, he says, according to Zen, the problems of the deepest level are to be resolved by resorting to your experience rather than intelligence. What does it mean? In Zen vocabulary, know by yourself whether it is cold or warm. So it is to find and know yourself whether, for instance, the water in the glass is hot or cold. By actually drinking from the glass, you will find it out it is cold or hot. To know the state of the water intelligently, that will be by way of using thermometer to measure the temperature. But if you drink from that glass, and then you will feel and know it's a tasty water, that's what is meant by knowing by yourself, by your own experience. Or I often draw an analogy to the hot springs. What is the best temperature for the hot springs? What are the chemical substances in the water? Well, if you scientifically measure them, then you know them. But the temperature of the water and the substances in the water, the efficacy or utility, rather than knowing such an information through the knowledge given to you, if you just dive into the water, then you will feel instantaneously that you feel comfortable without knowing the temperature nor the substances which are good for particular utility. Well, according to the recent the brain science, you call it qualia. I would call it the actual sensation. That may be something that differentiate a human from machine. I don't know whether how much closer machine could be. About, like, for instance, when you're moved by watching a beautiful flower, for instance. I believe that is hard to be achieved by machine, at least that's what I was told. Yes, what impresses us beautiful, or what is hot for human, you have to train machine. So according to a criteria, you have to train and teach machine. We can't expect such a criteria coming from the machine. Well, that's what has been achieved so far, I think. What kind of landscape or scenery that would move you, impress you? You can teach the machine with a huge amount of data. But talking about human, well, suppose that there are 10,000 people. All those people might be impressed with a particular flower and think they are beautiful, but if you are after heartbreak, then you won't feel it beautiful. Or even when something that is ugly, not beautiful for many people, one particular individual might feel that it is beautiful. You know that there is Mitsuo Aida Museum here. And according to him, the beautiful mind is what can feel something beautiful as beautiful. And that's what we cherish in Zen teaching. So your sensation of feeling to teach machine that this is beautiful and that is beautiful, and eventually such data would be accumulated, and if there is commonality found, then that could be applied to the new domain. But in the case of hot springs, you know by experience that it is a good hot spring, that you will feel comfortable. But then the question is, what is good about extracting commonalities? How is it viewed in Zen? If it is just based upon your experience, then there is no way of communicating that to someone else. Just say that I really enjoyed the hot spring. But if you try to disseminate the knowledge universally, then the temperature, which is considered as optimal, and this is this substance and that's good for your health, such intelligent or intellectual interpretation would be added to make it more universal. But in the case of Zen sect, your own experience is considered as most important in the first place. And then in order to convey that to others, whereas history, logic, philosophy, they are there to complement you. So those two are not incompatible with each other, but rather, according to Zen, you can use science and others to complement you. Yes, so your experience is most important, but then comes logic and reason that would support that experience. While attending the morning session, I thought I became a little bit wiser and more intelligent. Well, science and technology are advancing, and therefore, in our daily life, science and technology are now spreading, including information technology and medical science. We are seeing exponential growth of applications of science and technology in those domains. And what is your view on progress of science and technology? Well, we reside in Temple, and this is the 21st century, and yet we use firewood, we split wood and then use it for instance, cooking, and then pump up the water manually from the well. But of course, I did not travel here on the traditional the transportation means. Rather, I ride on the train. If it is the some distant place, then I might choose to travel by Shinkansen or bullet train. So I do appreciate modern technology. And talking about the human body, thanks to medical science, and yet there is something that the human body cannot be completely taken care of by medical science. In other words, human body has not advanced to a great extent that is comparable to the progress of medical science. That may be the reason why, even when we have cars and trains and escalators, elevators in a station, or the automatic the pedestrian road, and yet when you have a leisure time, then you might feel like jogging around the Imperial Palace, and I do as well. I really enjoy running. That means human body has not drastically changed. And because human body has not caught up with the transformation and changes of the science and technology, there is a kind of a struggle and dilemma, and that's what we are focusing on. Despite the progress on science and technology, for instance, I had a cold recently. There is no the good medicine to cure cold, the common cold, or the hay fever. There is no complete cure yet. That means human body that is still primitive, and we have to be modest in accepting that. So the voice coming from inside your body might be shouting for help. You have to listen to your the voice from your body. Listen to the voice that is coming from inside your body. That's also important. Here we are talking about AI, artificial intelligence, as it reads, something that is created by human as artificial intelligence is now introduced, which could affect our way of thinking and even our knowledge and intelligence. In other words, new intelligence is being created artificially. What do you make of? Well, I don't know. I won't be living long enough to see major impact that would be produced by AI. Maybe something that is beyond our expectation might come out, then I will be just astonished. Well, I heard about the wild boar. Yes, there is no such wild boar that is larger than the mountain. But maybe there may be the mountain-sized wild boar and big the wild boar may be chasing us. Well, it's beyond our imagination. Because time is so limited, I'd like to come to the last question on my list. And I'm sure all of you are interested in this question. According to Zen, how do you interpret the human mind and consciousness? And how do you pursue the mind and consciousness? The consciousness or the brain function? I believe Zen has been pursuing those questions with a long history. One is by way of the seated meditation. In view of outside information, the question is how you would respond to it. And that's not something that we are seriously pursuing. Rather, we are focusing more about dialogue within yourself. So, surrounded by outside, what is the state of yourself and how you're trying to improve and maintain the current state? That's what is considered as more important. So that with AI progress, the more it advances, and still, given the primitive state of human body, which cannot catch up with such disruptive technology, we often use expression like another yourself, the second yourself. That is, you look at yourself on your own and try to modulate your state. And that kind of practice might become more important. I was watching a TV program where you were actually stating something like self-regulation learning. And that again refers to what extent it is necessary to learn and what you need to learn. That means the need for your knowledge as to, or your ability to learn yourself. According to Buddha, you have to be healthy and you have to know satisfaction and the peaceful state of mind. Health, that's about your body, and to know about satisfaction or fulfillment, that means this much is enough for me. Or in view of progress and technology, you have to make a choice whether you need this much but you don't need any more. You have to question yourself, your body, and then try to find out what's important to you, what you need, and then you have to make a judgment according to your ability to modulate and regulate yourself, and then try to maintain the peaceful state of mind. Otherwise, no matter how much convenience is brought about by the technology, if you are unhappy, that will be too sad and pitiful. I read your book. Thank you. And according to that book, the two Chinese characters express seated meditation. The first character consists of Chu, people, and earth. That means two people are sitting and facing each other. And your own self, emotion, and that's what is represented by one part of that character, meaning person. And there is another person in this Chinese character, that's another self, and they are facing each other. So in other words, it's about eyes to look at yourself. I believe such eyes would become even more important in the future. And I believe time is up. I want to go home. But thank you very much. Well, even in science, actually objective measurement as well as some subjective observation is also considered as important means. And that is put forward. So I believe there is something commonality between the two. Well, I really wanted to continue this session, but thank you very much.